Hello, dear students. Very good morning. So we are learning the chapter atoms and molecules, right? So you are very well know about these water atoms and water molecules that you have already studied in your lower classes, right? So atoms nothing but atoms are the smallest particle of an element. So it is called as an atom. And molecules means two or more elements combined to form a substance that is called as a molecule. So coming to this history of this discovery of an atom. So ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. So the idea of divisibility of matter was considered long back in India. So around 500 BC, 500 before Christ, an Indian philosopher, Maharshi Kanad. Okay, his name is Kanad, Maharshi Rushi Kanada. So he was the first one postulated that if we go on dividing any matter, so according to him matter nothing but padartha. So ಏನಾದ್ರೂ ಒಂದು ಪದಾರ್ಥ nothing but, so that is called as matter. So he postulated that if we go on dividing the matter, so we shall get a smaller and smaller particles, right? Ultimately a time will come when we shall come across the smallest particle, so beyond which further division will not be possible. Okay, so according to him, so what he postulated means if we go on dividing any matter, so we shall get a smaller and smaller particles. Ultimately a time will come when we shall come across the smallest particles beyond which further division will not be possible. So and he named these particles are called as paramanu. So in English that is called as atom. So atom nothing but a paramanu. It means the smallest particles of a matter. ಒಂದು matter ನ ಒಂದು smallest particle ನ ಪರಮಾಣು ಅಂತ ಕರೀತಾರೆ. So that is paramanu nothing but atom. So and another Indian philosopher, his name is Fakuda Katyayama. Fakuda Katyayama is also an Indian philosopher. So he elaborated this doctrine and said that these particles normally exist in a combined form. Okay, so combined form means, so I told about molecules, right? So element and element will combine to form one substance. Okay, he explained about the particles normally exist in a combined form, which gives us a various forms of matter. It gives us a various forms of matter. So after around the same era, an ancient Greek philosophers, so name is Democritus and Leucippus. Okay, Democritus and Leucippus. So they suggested that if we go on dividing the matter, a stage will come when particles obtained it cannot be divided further. ಸೊ ಅಷ್ಟು ಸ್ಮಾಲೆಸ್ಟ್ ಆಗಿ ನಾವು ಡಿವೈಡ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಯಾವುದೋ ಒಂದು ಸ್ಟೇಜ್ ಬರುತ್ತೆ, ಆ ಸ್ಟೇಜ್ ಅಲ್ಲಿ ವಿ ಕೆನಾಟ್ ಡಿವೈಡ್ ದ ಮ್ಯಾಟರ್ ಫರ್ದರ್. ಸೊ ದಿಸ್ ಡಿಮೋಕ್ರಿಟಸ್ ಕಾಲ್ಡ್ these indivisible particles called as atoms. Okay, he call it as indivisible atoms or indivisible particles. So all this was based on a ಫಿಲಾಸಫಿಕಲ್ ಕನ್ಸಿಡರೇಷನ್, ಅಂದ್ರೆ ಒಂದು ಬರೀ ಥಿಯರಿಟಿಕಲ್ ಕನ್ಸಿಡರೇಷನ್ ಅಷ್ಟೇ. ಸೊ ಇದ್ರ ಬಗ್ಗೆ ಯಾವುದೇ ಒಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ನ ಮಾಡಿ ಅವರು, ಸೊ ದೇ ಡಿಡ್ ನಾಟ್ ಶೋ ಎನಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ಪ್ರೂಫ್ಸ್ ಅಂಡ್ ನಾಟ್ ಮಚ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ವರ್ಕ್ ಟು ವ್ಯಾಲಿಡೇಟ್ ದೀಸ್ ಐಡಿಯಾಸ್. ಸೊ ದಿಸ್ ಕುಡ್ ಬಿ ಡನ್ ಟಿಲ್ ದ 18th century. By the end of the 18th century, scientists recognized the differences between elements and compounds, and naturally it became an interest in finding out how and why elements will combine and what happens when they combine. So these doubts are arising in the 18th century. So another scientist, that is Antony L. Lavoisier. So he laid the foundation of chemical science by establishing two important laws of chemical combination. ಓಕೆ, ಇಷ್ಟೊತ್ತು ಇಂಡಿಯನ್ ಸೇಜ್ ಆಗಿರ್ಬೋದು, ಮತ್ತೆ ಪಕುದ ಕಾಟ್ಯಾಯಮ ಇರ್ಬೋದು, ಡಿಮೋಕ್ರಿಟಸ್, ಲ್ಯೂಸಿಪಸ್. ಸೊ ಇವರೆಲ್ಲ ಹೇಳಿದ್ದು ಬರೀ ಥಿಯರಿಟಿಕಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ರು, ಬಟ್ ದೇ ಡಿಂಟ್ ಶೋಡ್ ಇಟ್ ಇನ್ ದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ಫಾರ್ಮ್. So this Antonio L. Lavoisier, so he laid foundation of chemical sciences by establishing two important laws of chemical combination. So ಇದು first laws of chemical combination ಅಂತ ಹೇಳ್ತಾನೆ. So in that there are two different types of laws. One is law of conservation of mass, law of conservation of mass, and law of constant proportions. So these are the two different laws of combination. It was first explained by Anthony L. Lavoisier. First law is law of conservation of mass. So students, you are very well know about this law, right? So here this law states that energy can neither be created nor be destroyed in a chemical reaction. Okay, so it is called, once again I'll repeat, energy can neither be created nor be destroyed in a chemical reaction. So this is the law of conservation of mass. Okay, we'll take one example. Suppose when a zinc reacts with a sulfuric acid, it will give zinc sulfate and hydrogen will be released. So here chemical reaction has taken place, right? Students, you know that in any chemical reaction there will be mainly two important parts. One is reactants and the product side, RHS and LHS. So here the mass of the RHS should always be equal to the mass of the LHS. So LHS ಮತ್ತೆ RHS ಎರಡರದು ಮಾಸ್ ಸೇಮ್ ಇರಲೇಬೇಕಾಗತ್ತೆ. So see here, what is the amount of zinc? Only 1. So in the product side also the amount of zinc is also 1. And here of course the chemical reaction has taken place. Amount of SO4. So here also SO4 is there, only one molecule, right? And the hydrogen. So here H2 is there, here also H2 is there. Okay, here the mass of the reactants should always be equal to the mass of the products. So here it says that so energy can neither be created, here energy is not created, and even we have not destroyed it. So the energy remains same here and in any chemical reaction, but we can convert from one form to another form. So energy can neither be created nor be destroyed in a chemical reaction, but we can convert from one chemical substance into another chemical substance. ಈಗ ನೋಡಿ, zinc 1 ಇದೆ, 1 molecule ಇದೆ, here also there is 1 molecule. Hydrogen 2, here also 2. So sulfur 1 and here also 1. So oxygen molecules 4, here also 4. So you know about balanced chemical equations, right? So here it says energy can neither be created nor be destroyed in a chemical reactions. Next law is law of constant proportions. So constant proportions means in a constant ratio. So in a chemical substance, the elements are always present in a definite proportions by mass. So for example, you know that water, right? So water molecular formula is H2O. So 2 molecules of hydrogen and 1 molecule of oxygen. So ಇದೇ ತರ it will be combined in a constant proportion. So H3O ಆಗಿ ಇರೋದಿಲ್ಲ, it will be present in a constant proportion, that is H2O. So Lavoisier along with other scientists noted that many compounds were composed of 2 or more elements and each such compound had the same elements in the same proportion. So ಯಾವಾಗಲೂ ಸೇಮ್ ಪ್ರಪೋರ್ಷನ್ ಅಲ್ಲೇ ಈ ಕಾಂಪೌಂಡ್ಸ್ ಕಂಬೈನ್ ಆಗತ್ತೆ ಅಂತ. So we'll take that is irrespective of where the compound came from or who prepared it, ಯಾರೇ ಮಾಡಿದ್ರು ಹೇಗೆ ಮಾಡಿದ್ರು ಅದ್ರ ಕಾಂಬಿನೇಷನ್ ಮತ್ತೆ ವರ್ಡ್ಸ್, so combination and chemical formation will be same. We'll take one example, that is water, H2O. So here whenever the water is water, how the water is, maybe whatever the source it may be, it will be available in the ratio 1 is to 8. One is hydrogen, 1 gram of hydrogen and 8 grams of oxygen. ಸೊ ಇದೇ ರೇಷಿಯೋ ಅಲ್ಲಿ ನಮಗೆ ಸೊ ವಾಟರ್ನ ಫೌಂಡ್ ಮಾಡೋಕ್ಕಾಗುತ್ತೆ. This led to the law of constant proportions, which is also known as law of definite proportions. Okay, so this law was stated by Proust as in a chemical substance the elements are always present in a definite proportions by mass. Okay, so ಇದು ಎಷ್ಟು ಪ್ರಪೋರ್ಷನ್ ಅಲ್ಲಿ ನೈಟ್ರೋಜನ್ ಎಷ್ಟು ಪ್ರಪೋರ್ಷನ್ ಆಗಬೇಕು, ಯಾವುದೇ ಒಂದು ಕೆಮಿಕಲ್ ಕಾಂಬಿನೇಷನ್ ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ, so there how much amount of nitrogen, how much amount of hydrogen, so based on that only, so the chemicals will combine. So after all these things, the next problem faced by scientists was to give appropriate explanation of these two laws. So after Lavoisier, a British chemist known as John Dalton, you are very well know about him, right? So he is John Dalton. So John Dalton provided the basic theory about the nature of matter. So Dalton picked up the idea of divisibility of matter, which was still then just a philosophy. Alva ishtuvargu, so atom is just a indivisible particle agi ittu. So which was still then just it's a philosophy. So he took the name of atoms as given by the Greeks and said that the smallest particle of matter are atoms. So his theory was based on the law of chemical combination. His theory was based on the chemical combination. So Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportions. So you know about him, right? John Dalton, he was born in a poor weaver's family in 1766 in England. He began his career as a teacher at the age of 12, and 7 years later he became a school principal. In 1793, Dalton left Manchester to teach the mathematics, physics and chemistry in a college. So he spent most of his life there teaching and researching. In 1808, he presented his atomic theory, which was a turning point in study of a matter. Okay, atomic theory, ಸೊ ನಮ್ಮ ಇವಾಗ ಏನು ಅಟ್ ಪ್ರೆಸೆಂಟ್ ನಾವು ಎಲ್ಲ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಆಟಮ್ ಅಂತ ಡಿಸೈಡ್ ಮಾಡ್ತಿದ್ದೀವೋ, ಇಟ್ ಈಸ್ ದ ಇಟ್ಸ್ ದ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಇನ್ ದಟ್. Okay, according to Dalton's atomic theory, all the matter, whether an element, a compound, a mixture, it is composed of a small particles called atoms. So the postulates of a theory may be stated here. So the first one is all matter is made up of very tiny particles called as atoms. So ella atoms kuda very tiny particles inda agide, and atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. So you have already learnt it, right? You cannot destroy it, or you cannot create it. And atoms of a given element are identical in mass and a chemical properties. Each element has its own mass. For example, hydrogen molecular mass is 1. Helium, so mass is 2. So it just like that. Okay, every atom, every element is identical in mass and they have a chemical properties. And next one is atoms of different elements have a different masses and chemical properties. Okay, different elements andre so all the elements are different from one another. Even though, for example, nitrogen, oxygen and carbon dioxide, if you take, all are gases only, but the property and the chemical combinations and the reactivity of each element is different from one another. Atoms of different elements have a different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form a compounds. As I already told, H2O, how much amount of hydrogen, how much amount of oxygen, so it will be present in the whole numbers. And next is the relative number and kinds of atoms are constant in a given compound. So as you already studied H2O, so the number will always be constant for a given compound. ಇವಾಗ H2O ಗೆ 1:8, so ammonia ಗೆ 14:3, so this will be same. So you will study about these things in the next structure of atom in a structure of atom chapter. So these are the Dalton's postulates. So students, what are the modern day symbols of atoms of different elements? You know about atom, right? It is the smallest particle of an element. And here there are some modern day symbols of atoms of different element. So you know that Dalton was the first scientist to use the symbols for elements in very specific sense. So when he used a symbol for an element, he also meant a definite quantity of that element. That is one atom of that element. Okay. So next is Berzelius. Berzelius suggested that symbols of elements be made from one or two letters of the name of the element. Okay, ಆ ನೇಮ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್ಗೆ ಯಾವುದಾದ್ರೂ 1 or 2 ಹೆಸರು ನೇಮ್ನ ಇಡಬೇಕು ಅಂತ. Here you can see, so hydrogen indicates this, carbon, oxygen, phosphorus, sulfur, iron, here you can see. So copper, lead, silver, gold, platina and mercury. So these are all the symbols of some elements proposed by the Dalton. So this is about the topic laws of chemical combinations and introduction to the atoms and symbols which we used by the Dalton for different elements. And I hope all of you have understood. Thank you.